Okay, shall we start? You guys are ready with your pen and paper and all? Okay, okay. So let me start with a concern that I raised previous class. Okay. You guys are able to see the problem, right?
Yes, yes.
Okay. Uh, Please find the initial value of this YT and tell me what you guys are getting.
Sorry, what?
Anybody else?
1/2.
1 by 2. Okay.
Infinity.
Infinity. Okay. That is an interesting answer. Who is that? Who said
Sadat.
infinity? Okay, that is interesting, right? At t equal to 0, it is infinity. Last day I raised this concern. You see, this is what is the structure of this? What is this I have written? What is this? S plus 1 divided by S plus 2. What is this? This is a lead lag compensator, right? There is a 0 at S is equal to 1 minus 1, and there is a pole at x is equal to minus 2. And the problem that I told previous day, you couldn't appreciate the problem because that day by applying initial value theorem you got the answer. Today, while solving this sum, you would appreciate why I was saying what I was saying the previous day. Yeah, actually, you see, when is final value theorem not applicable? Anubhav, Navkirti, Shahadat, anyone? When can you not apply final value theorem? When does final value theorem fail? Anubhav,
Yes, sir.
when does final value theorem fail?
Unstable systems.
Correct. When there is a pole on the right hand side of the S plane, final value theorem will not work. So, and what is the case with initial value theorem? Is it applicable everywhere? Anubhav,
Yes,
is
yes.
initial value theorem
Sir,
applicable? Yes.
in the last session, you have told that we can apply that only for proper functions.
Proper functions. Right. Right. Now today you will see why it is so. I will show you. Now see, look at the structure of this transfer function. Let us see why are we facing problem. You see, Shadat came with this problem. He has encountered this problem. So limit s tends to infinity, s into ys. That becomes infinity. It is truly infinity. The problem is, if you break this function, yt equal to delta t minus e to the power minus 2t ut. This is basically 1t, that is Heaviside step function. It is similar to what you write as ut, but in control literature, ut is variable which is used for input. That is why I use 1 of t. So see, at t equal to 0, there is a delta t term over there. So it is kind of unbound. So if you're asked to find, initial value of such functions, you are asked to find the value of yt at t equal to 0 plus. At t equal to 0 plus, this will not exist. This will not exist. So what you end up getting is minus of 1. This is the sum you should, this is an example you should keep in mind, because a similar sum I illustrated the other day. You didn't face a problem because the sum was structured in that fashion, but here you would face a problem. So this was something I wanted to illustrate, because last day I told the thing how to approach this sum, but I couldn't illustrate how to do it. So remember this. So you cannot apply initial value theorem when it is unbounded. Delta t has a value of infinity at t equal to 0, so you cannot do that. So you have to find, if you are asked to find t equal to at initial value, then you have to find the value at t equal to 0 plus. So at that case, delta t becomes equal to 0. You are left only with the second part of the system, and you get the value as minus of 1. Keep this in mind. This is an important concept. We are recording this, right? Recording is on. Yeah, okay. Okay, now let us move to the second sum. Okay, second sum. Yeah. Let us do the sum. Okay. So signal flow graph has been given to you, and it is told that there are two inputs, U1 or U2. So and there are two outputs, Y1 and Y2. Which of the combination would you choose? Would you choose U1 and Y1, or U2 and Y2, or U1 and Y1, or U2 and Y1? Which combination you would choose such that the entire system becomes controllable and observable? You have two choices. One is U1 and one is U2 for inputs. You have two choices, that is Y1 and Y2 to be your outputs. I will give you 3 minutes time to try the sum, and then I would see which one which is correct. Anyone with the answer yet?
D.
D. Okay. Okay. Anybody else? Navkirti, why do you think it is D?
So because U2 is so because of the way arrows are at U2 and Y2, I just thought it to be this.
Okay. Okay. Yeah, I mean the arrows are given in such a fashion, you see, because y2 will have information about x2 and x1, and then if I take u1 as the input, then it is going to the bottom portion as well as the top portion. So it feels like if I take u1 and y2, it would be controllable and observable from. I mean, if you look at the output y2, it would be observable because it contains information about x2 and x1, and it seems as if if I control this u1, then I can control both of these. This is what our intuition says, but is it true? That is the question. I mean, it is a gate examination. Okay, so you need to verify your intuition. Okay, it's already 3 minutes, maybe it's 4 minutes. So let us go ahead with the solution. It is not, the answer is incorrect. It is not the right answer. So as I told you, intuitively you will feel that if I choose u1 as my input and as y2 as my output, then it would be controllable and observable. But it is not so. You cannot jump to a conclusion just by looking at the direction of the arrows. You have to work out something. It's a 2-mark question. It's a lengthy question. So first, what we will do is we will write the state space equation from the signal flow graph. So you see this is x1. So this is the integrator over here. So this point must be x1 dot. So x1 dot is equal to 5 of x1 plus u1 minus of 2 into x2. That is what I've written over here. The first equation. Now look at x2 dot. So this is x2. I integrated before it. So this x2 dot. This point is x2 dot. So what is x2 dot? x2 dot equal to 2 into x1 plus u1 plus u2 plus x2. You see, this is what the equation I've written over here. Similarly, y1 we have x1 and y2 we have x1 minus of x2. Okay. Okay, please ignore this. There's some mistake over here. Leave it. Okay, just give me a minute. Just give me a minute. Yeah, this. Okay. Okay. So now, yeah. So if you write the equations, what we have is y1 is equal to x1 and y2 equal to x1 minus x2, as I have seen over here. Y2 equal to x1 minus of x2. So if we write in the matrix form, you will get the set of equations as shown in this figure. Okay, yt equal to, so y1 is the upper element, that is equal to x1, and the lower element, that is y2, that will be x1 minus of x2. Similarly over here, what we have, 5 into x1 minus 2 into x2 plus u1. So there is element 0 over here, so u2 becomes equal to 0. So this is the set of equations that you get. Okay, now just like Navkirti has thought, or anybody else would have thought, let us see whether our intuition is correct or not. So what I have done is I have taken y2 as my output and u2 I have put 0, that is I have considered u1 as my input, and I've written the set of equations. So in that case, what would happen? I am setting u2 equal to 0. So the lower row would go to 0. So only we have, sorry, the first column would remain. This column would go to 0 because this is associated with u2. So I am putting u2 equal to 0. That means this column is gone. So I am left with 1 and 1 of u1. Similarly, I have told that y2 is the only output. So the lower element will be gone. So I am left with not the lower element. What is the u2 is the only. So the lower element is only there. Y1 is gone. So the upper row is gone. So you have 1, minus 1, x1 and x2. So because y2 we had was x1 minus x2. So from there you write your set of equations. Now what you have to do, you have to check whether this what you have got is controllable or not. So for that we have to make the controllability matrix. So how to make a controllability matrix? That is already known to you. So we have A matrix as this one, that is 5, minus 2, 2 and 1. B matrix we have 1 and 1 over here, and C matrix, that is 1 minus 1. So let us now form the controllability matrix. That is the first column of the controllability matrix will be the B matrix, that is 1 and 1. Now we have to go through this operation A into B, that is this matrix multiplied by this matrix, and you would get a column matrix. So what is that column matrix? Column matrix is this 3 and 3. So you see this, the rank of this matrix is 1, because if you divide this 3 by 3 and subtract it from the first column, you would get 0 column over here. Or the other way you can check is you can check the determinant of the matrix. The determinant of the matrix is 0. If the determinant is 0, that means it is not, I mean the order of the system is not equal to the rank of the system. The rank of the system over here is 1, whereas the order is 2. So it is not controllable. Similarly, we would form the observability matrix, that is the C matrix and CA. You have to conduct this operation C into A, and you will get that observability matrix as 1 minus 1, 3 minus 3. This again you will see that the rank is 1. It is not equal to 2, which is the order of the system. So it is neither observable nor controllable. So whatever our intuition was saying was totally incorrect. So do not always trust your intuitions. You have to know the cracks where where your intuition will fail, where the theory that that your mind has would fail. That is where the EA comes in. So now we'll check the other case. That is, we would take u2 as my input and y1 as the only output. So that is the only case I have. These are exactly the two cases. The options are 4, but exactly these are the two cases that you have. So if I set u1 equal to 0, that is my only input is u2 and y1 is my only output. In such a case, you have the set of equations as shown on the screen. And again, you form the controllability matrix by the way I have just told you. That is, the B matrix would be the first column. So you see the first column is 0 and 1. That is the B matrix. If you do the operation A into B, that is, you multiply this matrix with this matrix, then you get minus 2 and 1. So now you see the determinant is no longer 0. So the rank of this controllability matrix is now equal to 2, which is equal to the order of the system. So if I choose my input variable as u2, then we find that it is controllable. Okay. Now let us see what happens to the observability. So if we look at the observability matrix, that again is the similar operation that we have conducted, that is C and CA. What we see is, again in this case, the determinant of the matrix is not equal to 0. So the observability matrix has a rank equal to 2, which is equal to the order of the system, and hence the system is observable when the output is y1. Okay, the correct option is B, not D. So the correct option will be B. Okay. Okay, so let us go for the second sum. The second sum has told you that there is a transfer function which is a second order second order transfer function, and it has a perfectly flat magnitude response and of unity magnitude, and it has a pole at 2 minus of j3. So you need to find all the poles and zeros of the system. I will again give you 3 minutes time to solve, and then I will ask what answers you are getting. Anybody with the answer yet?
Option D.
Option D. Okay, that is Shahadat, right? Who was that?
Yes.
Okay. So can you please explain why you have said it is D?
So the pole have to be conjugate symmetric.
Absolutely.
Hence, the poles will, because there is a pole at 2 minus J3, there will have to be a pole at 2 plus J3.
Absolutely.
Now, because the magnitude has to be unity, so
Yes.
in the denominator of the transfer function, we'll have root of 2 square plus 3 square. So 2 square plus 3 square, which is 13. So we'll require
So you
zeros,
have
which will
s
also.
minus something, right? You do not have that. The 2 square plus 3 square is not, this is a 0. So the polynomial you have is s minus of this thing. S plus 2 minus j3 or s plus 2 minus j3. Yes, tell.
Yeah. So yeah, so the numerator will have to again take the magnitudes
Mm-hmm.
in the similar fashion. So in denominator we'll have s minus 2 plus j3 and s minus 2 minus j3. So if we take the magnitude of it, it will be s plus 2 whole square plus 9 and
Yes,
yeah.
you are correct. Your approach is correct. But what I will do is I will give you a geometrical interpretation of this thing. Okay, what exactly we are doing? Why are we? I can understand it is very obvious, but I will try and give a bit of a geometrical interpretation. This would help you in understanding Nyquist plot. Nyquist plot, we do something similar to this, but not this actually, but something you understand it better. The reason I am saying is, so you have already mentioned that we have one pole at 2 minus 3j. So as the conjugate, as a complex pole, and complex pole exists in conjugate pairs, so there will be another pole at 2 plus 3j. Correct, absolutely correct. Now what about zeros? Okay, so we do not know about numerator polynomial as of now. So you see why when we find the frequency response of a system, how do you replace s? What do you replace s with?
J
Shadat?
omega.
J omega, right. Why do you replace s with j omega?
That's the definition.
No, it is
Definition
no,
is
s we define as rho plus j omega. But whenever you are finding the frequency response, finding magnitude or angle, you just replace s with j omega. Why do you do that?
Frequency response is the output to sinusoidal input. And
Correct, because while experimentally finding frequency response, we input that with sinusoidal excitations. It has a fixed frequency but no decaying factor. It is a purely sinusoidal signal with no decaying factor. So the rho term s is equal to rho plus j omega that we say, the rho term equal to 0 while we are exciting system. We are replacing the frequency of what we are exciting with. Okay, so now see, so you have said that s equal to j omega. So s equal to j omega may be any point on this line, imaginary s, right? Imaginary s is j omega, correct?
yes,
Okay, so what is s minus p1? So s minus p1, so for simplicity I have taken a point on this, just like the analogy that you just said in your answer, s equal to 0. It may not be equal to 0, it may be any point on this j omega axis. So in that case the vector would be from here to here. So if you have chosen some point from here, you would have chosen a vector from here to here. Okay, so s minus p1 is a vector which is joining this point and this point. If you had chosen s somewhere over here, it would have been the vector would have been from this point to this point. Okay, now this, as you need the magnitude to be unity in the numerator polynomial, you need to have such two other vectors whose magnitude must be same. So in that case, what you do, you choose you need to have two such zeros. The red arrows, that the red vectors that you see, these are the denominator vectors. They have to be cancelled out by this blue vectors over here. So magnitude of these two vectors has to be equal. In such a case, so if you had chosen s over here, then also it would have been same. This vector and this vector would have the same length. Again, this vector and this vector would have the same length. So you have 0 at minus 2 minus 3j, and another conjugate of this z1, that is minus 2 plus 3j. So these are the locations of the zeros that we have. So the correct option is D. Shahadat was correct. Good. Okay. So this is the next sum. Okay, this would be the last sum, I think. Okay, this will be last sum. Okay. I would again give you 3-4 minutes to solve, and then you can. This is a pretty easy and straightforward sum. Just tell me. Anybody with the answer yet?
Option B.
Option B.
Yes.
Okay. Anybody else? Anybody else with the answer?
D.
Huh?
D.
D. Okay. Okay, let's see what is the answer. Okay. The first, let us convert this block diagram into a signal flow graph. Okay. I don't think either of the answer was correct. Anyways, let's see. So if I do the signal flow graph, what we find is there are two forward paths. One is through G1 and another is through G2. And there is, from this point, this is the output point. From there is a feedback signal which has a gain minus of H. So you have a minus of H over here. Similarly, over here also you have minus of H. So there are two such loops, minus of H and here also minus of H. And from here you get the output Y of S. Now let us use the Mason's formula and you can list down all the gains that we have. So the forward path gain we have G1, that is the small g1 is equal to G1 because this is the forward path gain G1, and another path gain that we have over here is G2. The loops that we have is minus of G1 into H. This is the loop minus of G1 into H. We have another loop that is minus of G2 into H. Then we see that neither of the loops are non-touching. Both the loops are touching at this point. So what we have is delta that we have in the Mason's gain is defined in the fashion like 1 minus sum of individual loop gains plus sum of all non-touching loops. So neither of the loops are non-touching. So all these terms will go to 0. We have only 1 minus L1 minus L2. So we have 1 plus G2 into H plus G1 into H. Delta 1 again becomes equal to delta 2, which is equal to equal to 1. So in that case, if you find the transfer function, please excuse the typo error over here. There are some typo errors. It's better I open this. Okay, just a minute. Yeah. So we have delta 1 which becomes equal to delta 2, which is actually 1 minus sum of individual loops which is not touching G1, as both the loops are touching at this point. So it is touching the forward path gain at this point as well as the loop at this point. So there are no non-touching loops. So delta 2 also becomes equal to 1. In such a case, we have is ys divided by xs, that is equal to G1 into delta 1 plus G2 into delta 2 divided by delta. That becomes this G1 plus G2 divided by 1 plus G2 into H plus G1 into H. So the correct answer is C. So none of the answers was correct. Okay. Well, let me see if I give another sum.
So this was the first time I got that diagram correct, and this is thanks because of your 3-minute limit.
Okay, good. Keep trying. So this is more like a this learning to ride a bicycle. In the beginning, it's difficult. After a certain period of time, you'll get the hang. Let me see if I have some extra questions. I will just. Where did I? Okay, let me see if I have some extra questions. No, this is the same question. Okay, yeah. So I'm giving you a function like this. Okay, signum function. I hope you know what signum function is. I have already drawn the function over here actually. I am not supposed to show the solution right now, but okay, the signum function has been given over here, and the Fourier series expansion of signum of cos of t is asked. So which one would be correct?
Yes, yes.
A. You are saying A. Option A, right?
Yes, sir.
Okay. Anybody else? So why are you saying A, Anubhav?
Odd way,
Yes.
odd, odd nature है.
ऑड नेचर है. ओके, और कुछ नहीं है, सिर्फ ऑड नेचर ही है.
Not half wave symmetry.
ओके. Anybody else? What is he right? What is he saying?
Sir, I'm only sure about sine terms, not about harmonic.
Okay. Okay. So can you plot this function signum of cos of t? Can you plot the function?
It's a pulse.
It's what?
It's like a pulse waveform. A square wave
Okay.
from 0 to 1 it is 1, and from -1 to 0 it is -1.
Okay. Okay. So what are the harmonics that can be present over there? What are the harmonics? Is it half wave symmetric?
Yes, sir. It has half wave symmetry.
So if it is half wave symmetric, then what do you think would be the correct answer?
No even harmonics.
No even harmonics, okay. But then why cosine terms are given?
D, sir.
What did you say?
D.
D.
Yes, sir.
Okay. You can see the waveform now. How I have plotted it. For the range where cosine is positive, it would be plus of 1. Range where cosine becomes negative, it becomes negative. So this is a even function, it is not odd function. Okay. Okay, Anubhav initially said, but he changed his answer.
Sir,
Good. Yeah.
uh, I was just seeing Signum. I was
Yeah.
plotting for Signum X by mod X. I didn't see cost T.
Okay. So what we see is it is an even function, and it also has half symmetry. What does half symmetry mean? You cut this half of the wave, move it forward by t by 2, and then you know take a reflection across this t axis. If these two matches, then you can say it is halfway symmetric. You take this half of the wave as I am showing by my cursor, place it on top of this, and then take a reflection of this part across this t-axis. If these two matches, then you can say that this signal is half-wave symmetric. So in this case, you see it is perfectly half-wave symmetric, and hence we can say the odd harmonics will exist, and it is an even function, so cosine term will exist. So that is the answer. The answer is D. Good, good. You people are progressing. It is good to see that you people are practicing. Okay, maybe I do not have any more questions allotted to me. I only had 3 questions. Still, I have shown 3 or 4 questions. That is good. So maybe I would end the session today over here. I will meet again on next Friday. Keep practicing. Enjoy yourself. Enjoy the weekends. Bye then. Till then. Yeah. Thank you, Anubhav. Thank you.
I have one question.
Yes. Yes. Yes.
In the last problem, right?
Yes.
Because it is signum of cos of t, won't
Yes.
cos of t be its domain?
Cos of t is what?
Shouldn't
Yes.
cos of t be its domain?
Cos of t is the argument that I am passing.
Yeah, so its range should be the domain of the
Absolutely.
signum
Yes.
function, right?
Yes.
So if that is the case, then the whole function will not vary with respect to t, but it will vary with respect to the range of signum of t, right? Sorry, the range of cos of t.
Yes. But what are you trying to imply? I am not getting exactly.
So I'm implying that the domain of the final function will only be from -1 to 1.
Yes, that is what is happening over here. There is -1 to 1. The purple curve that you see, that is the domain of the function. That is
No,
-1 or +1.
that is the range, right?
That is the range. Yes, that is the range.
No, I am talking about the domain of it. So
The
its
domain
domain
is
will be
this. The domain is the red portion would be its domain.
correct. So that varies from -1 to 1, right? So that should be the domain, right?
Yes. Yes.
And in that case, the final function will only be from -1 to 1, right?
Yeah, but it will only show you this, the show you one cycle of this car, right? That will only show you one cycle of this entire car. That would just be one cycle of it.
Okay.
Okay.
Thank you.